Hello, everyone, and welcome to this session. We are really honored to be able to speak at the Open Source Summit North America. And we are very sorry that we have to change this to a virtual speech at the last minute because our visa problem. So let's start. And our topic today is the openEuler, bringing new opportunities to the diversified computing era. And it's presented by me and my colleague, Zhong, and we are from the openEuler community. The content of today's session will be divided into three parts. First, we will have a look at what is the openEuler community, and then we will go through some technical details about the community and some ideas behind them. And then Zhong will take you to the behind the thing to see what kind of infrastructure that we used to build up the community in this large scale. And before we start, please let us spend a few minutes to introduce us. My name is Zheng. I'm from the openEuler community, and I serve both as a SIG maintainer and also the community manager of the openEuler community. And here is my email. Please feel free to contact me if you have any questions or interested in the openEuler community.
Hi everyone, I'm Zhong. You can just call me Zheng. I have 10 years of experience in open source development and management, contributed to OpenStack, Kubernetes, Chaos community, and so on. Currently, I'm an openEuler infrastructure SIG maintainer and also be a Chaos metric module working group maintainer. Let's clarify what the problem we try to resolve. There are some tough challenges for the OS industry. The first in development of chipset brings top challenges for the OS development. The chipset has been very bully in recent 5 years. In the future, we can forecast it. There are more and more new type of chipset will appear. So, the OS should need a more aggressive innovation to bring us to the highest and fast. So, the OS is special for the Linux system and to become bigger and bigger and behavior and higher. So, our idea is how to reduce it and reduce the size, reduce to make it higher and faster. And another gap is between the server and card and the embedded system, because the Linux system is divided to be a server and the embedded system there are two words. They don't sync very well, so there's another challenger. So, we will do some aggressive innovation or modification to resolve that kind of challenges. The openEuler will unleash diversified computing power to innovate enterprises. You can see it in the picture. The openEuler operating system support for all devices, and one OS also support for all applications. How does openEuler handle the new scenarios? So over here, we will have adopted this kind of way. We have the release. That's the normal way, right? We release a version 2 times per year. One is in the March, another in the September. Those releases we call the innovation release. You can put everything and measure and features into those kind of release. You can try to make us provide some environment to do the verification job. For 2 years, we will release RTS long-term server's version. We will make sure that the quality, and we will maintain the RTS for 6 years to ensure the company will adopt a major product. So that is the way. If you want to try something new to verify some cheapest, you can go very earlier to the innovation version cycle, and you can do the verification and go back to your RTS version. And so we will adopt more aggressively with release cycle to meet the aggressive with cheap. We will adopt very aggressive strategy to adopt those new features. So, you know, a new feature is specified for some big feature. It's not easy or spend a very long time for the upstream. Then, we have another important feature is we share the same code base in this point. We have released 2 out here for the second RTS in the 22.3, and this is very milestone version in this version. No matter what you are, what the choose server you use at 86 to create 3 kind of version. So if you are a developer to just click to use the API and you share the same API. If you are a device producer, the driver will face the same conversion. So we will reduce the gap between the usages of the new architecture. Okay, so is that the general information how we handle the cheapest issue, but it looks not aggressive, right? The openEuler community started from 2019. In 2020, the openEuler community committee was established. In 2021, the openEuler community donated to the Open Atom Foundation. After 3 years of development, the openEuler community has grown rapidly. The number of openEuler contributors has increased by 4 times. The number of openEuler version downloads has increased by 30 times. Growth will be even more than 2023. Currently, we have more than 800 community partners joining us for community development. Those community partners come from various industries, such as processor, server, OS, DB, and so on. Next, welcome to Zhenyu to bring us the second part of the content.
Thank you, Zhongjun. Let's get to the second part of this session. In this part, we would like to share some technical details about openEuler, and this might give you some ideas about why openEuler growing so fast in China. The first reason why openEuler grown so fast is that it is not just a distro for Linux. The community is actually much more than that. It is actually an innovation platform. Developers in this community worked on full software stack to fulfill user requirements. Let's take our latest LTS version 22.3 as an example. In this version, we used 5.10 kernel, and the major contributor for openEuler, Huawei, has been top 2 contributors to the Linux kernel for quite many kernel versions. openEuler has also done a lot to optimize about the OS on multi-architecture computing, as there are a lot of different types of chips in China. For example, we have to done some kernel architecture optimization for large-scale ARM clusters, and some user mode protocol stack. Also some HCK decoupled control which can provide 5% to 20% performance improvement. And now the above mentioned is still what a normal OS distro does. Let's see what else we have done. The openEuler developers have also created some projects to overcome the challenges they faced using the current projects. For example, the traditional Docker have too much overhead and the spawning time is slow in a large cluster. The openEuler developers and users created a project called Isula with Rust to provide much more lower overhead and much lighter weight. The Isula project has already joined the CNCF landscape. They also created the Stratowert project in the virtualization field for the similar reasons. With more and more users start to use openEuler, how to manage and optimize the whole cluster became a problem to the user cares. So openEuler also incubated ONM projects with latest AI technologies. Atune is the project that can provide AI-assisted cluster tuning to user services, and AOps can provide AI-assisted cluster operations such as security scanning, monitoring, live patching, and much more. openEuler has a lot of innovations also in security, programming languages, development toolchain, and many more. I'm not going to go through all of the details here. You are welcome to find it on the openEuler community website if you are interested. But I guess you already got my point. The openEuler community is not just a Linux distro. And now, let's have a look at some of the other ideas behind the openEuler community. As mentioned, openEuler is aimed at enterprise usage during its founding. So let's imagine this. Suppose you are a cloud admin in charge of 100,000 of machines. And it's in today's world, you will be probably face huge number of different hardwares, and each of them have different architecture or features. And there could be over 40 new CVEs every week. And believe me, the number could only be bigger. And according to many OS strategy, the OS releases updates per month or even per week. I have to say that we are not judging on those releases. We are just taking the fact as an example. I think if you are managing a cluster like this, your face would be like this cat every day, because all of the above mentioned action needs to be updated on kernels. And as more and more different chips versions come into the market, the kernel is facing greater challenges. It is because that the Linux kernel is highly coupled and unchangeable. We can say that changing anything means changing everything. You have to recompile them all. It could be really complicated if you are managing a larger cluster and you have a business running on them. And in openEuler, we come up with an idea to make everything in kernel as a service. We call it the kernel as a service, or KaaS. With this idea, we have to redesign the driver framework in the old kernel and to make the drivers more isolated. And we plan to use the eBPF technology to make those modules to be flexible and reconfigurable, such as the network services, the storage services, and the schedule services. By doing this, we will be able to provide a fundamental ability for our next step. From the above presented contents, you might already think that openEuler is aggressive in release, in kernel, and in innovation projects. And we have introduced the idea of kernel as a service. With those fundamental abilities, we are thinking about why not to become more aggressive. The idea is that why not create a universal OS platform that is usable for both data centers, edge, IoT, or embedded. If we want to do that, we have to provide abilities not only in OS itself, like in kernel and other components, but also need to have a powerful and suitable infrastructure behind the OS and the community build them in order to build up the OS that we want to create. Okay, let's first have a look at the current status of server and embedded OS and the potential gaps. In the current world, OS for embedded and server side is quite different. They care about different things. Embedded and IoT cares more about things like real-time, size, and others. Typical OS is like Wind River. Typical building tools is like Yocto. And on the other hand, at the server side, Linux kernel is typically the dominant OS. In this side, we currently care about things like virtualization and how to release compute power on different architecture, like we just mentioned. Currently, the main tools we use to build the OS is from the OBS from the OpenSUSE community and things like Koji. With the current status, the industry is divided into two parts, and because of this, everyone in the OS industry will have to pay double efforts to do the compliance work, especially for the chipset vendors. If they want to compete in both scenarios, they have to do driver and optimizations for both OS types, as they have different packaging techniques and different dependency trees too. Also, for application developers, the application cannot be deployed freely among different machines and OS platforms, also due to different build toolchain and different trees. But when we step outside, the main idea for operating system is to hide the details for hardware and to provide a uniform platform for applications and users. So on this level, we do think that it could be much better if we are able to create a uniform OS. On technical level, every OS is just a collection of packages, and with a toolchain to build all those packages, and also the OS itself. Alternatively, different OS can be thought as a distinct compilation of the packages, so we can come up with an idea. The idea is that the openEuler can be treated as a Linux distribution and also a composed system to make OS for different scenarios. We call it the tenant socket structure, which is used by traditional Chinese buildings. Like in the graph on the left, the base structure is solid and reliable, also small. We can, just as the key component of an OS, like the kernel, the driver, and etc. And with this base structure and a perfectly designed toolchain, we can compose different types of buildings. Like in the traditional Chinese building, we can build the Forbidden City and also a small pavilion with the same basic structure. This is quite similar to our OS story. We can use the same basic components to build up OS for different scenarios. We have already built some OS releases with these ideas and tools, and they have already have a very large-scale deployments. Zhongjun will also give some details about the building tools called Euler Maker in the next part. So with all the information I have just provided, we might have a new understanding about what is openEuler. It is actually not only an OS distro, it is actually an OS platform which builds different OSs. And the openEuler community has optimized OS components for lighter, modular designs that can run on multiple hardware platforms. And after that, openEuler uses these components to create and tailored OS solutions for different solutions. Okay, that will be all for the technical part. I hope you have a better understanding about what the openEuler community is and our ideas and thoughts when start this community. And now, Zhongjun will give you more details about the infrastructure behind this community.
Behind the scenes, there's a lot of work have to do. For example, how to measure issues from community developers, how to manage code merging, how to manage package imports. So, we need our own infrastructures for openEuler community. Let's take a look at the openEuler infrastructure landscape. We can find there are so many excellent and mutual projects that can be used to set up the whole infrastructure for our communities. So, take a look at this one. We will use the OpenSUSE OBS, that the Open Build service, for the open source projects to build our packages and distribute our packages. We will also use the Zhenyu mailman. Maybe you have Horizon Force as our mail list assistance. And you may also find that there are a bunch of the projects comes from the CNCF. Yes, we have the Nginx ingress, which is used as our reverse proxy service. And there's a simple API gateways. We also use Argo CD. This is a nice tool. We use obviously this to centralize our application. We also use the Vault from the HashiCorp, which is used as our sensitive data backend. And we will use another small tools to synchronize all the sensitive data from our Vault backend or our Kubernetes clusters where embeds all configuration files. And we also use the Copper. So we also use so many projects that already exist in other good open source communities, but we still do some fix or do some review or do some fix PR to upstream open source projects. And we also build our own projects for openEuler community. We can see so many applications we have to use. So, how do we develop the applications in our cloud-native way? There are 4 parts. The first part is about development standardizations. So, we need to upgrade the existing projects to make it running in Kubernetes clusters. We have to do the following several rules. The first one is about to calculate the application, one process per container. And the second one is about Kubernetes development semantics. So, we suggest our development to use Hillchar and customize to upgrade the development YAML files and output the standard log and the configuration if needed, because we will use the robot package and centralize all of the dates. That data by our secret manager tool. And we also ask our developers to restrict to push the image. Actually, we don't use the Docker Hub because we have some tools. Our private reports, which is used to scan the CVEs and to perform some checks before developed. We also trust the database images. For example, they are asked to use the openEuler based images. Just because one of the packing can be easily upgraded with some CVE issues has been fixed. And the last one is about to expose the health check endpoints. We need to restart up the applications by dedicating the health check endpoints. It will make our application more health. For the second part is about as a configuration separation. So there are 3 different rules in the whole process to develop the applications to our product environment. The first rule is the application developer who is responsible to write out the Docker YAML files, which is not contains any details for the development. For example, they don't need to care about any namespace or some other Docker or Kubernetes resources. For the second rule is our developer engineer, which is used to add more details to the YAML files which contain nice or HAL standards. The third part is our info maintainers, who is responsible for reviewing all the changes, all the applications in our communities. He is responsible to merge the pull request. So we just separate those 3 steps and separate those owner. It will make our server application more easy. Some of the projects is based on the existing operating projects, but some of the projects is based on the ideas we learned from other open source projects. There are 2 cases. The first one is above. The second one is like developer robot set application. First time, we trying to investigate the existing pro application. We found a pro application from CNCF, and it's a nice project. It has about 30 plugins that can be directly used in our environment. But the pro projects still have some issues and some performance problems. including once one of the plugins gets crashed. There's a whole Chrome application will get restored. That's the one problem. The second is sometimes when there are huge messages comes from the code repository, when the huge message comes, the pro application sometimes will lose the event. So for these two problems, we have to upgrade the pro project into our own robot. Its name is Yabert. So we have to improve it for several aspects. So the Yabert now supports every single plugin will be separate in the containers, and it's easy to replace, and if one of the plugins gets crashed, it will not affect the whole applications.
Thanks to Zhongjun for the excellent content. Now let me bring you to another new project in the community that we are currently working on. It is called the Signal Trust. It is aimed to provide a secure and efficient solution for signing Linux packages. It is a project based on the idea of OBS sign from the OpenSUSE and added much more optimizations according to our infrastructure team's daily usage and requirements. So it can provide a much more comprehensive and efficient and cloud-native solution for package signing, which is more suitable for our scenarios. We have done some performance tests, and according to the results, our new design is much more efficient, and we are using it in openEuler infrastructure. I'm not going to go through all the details, but you can contact our infra team if you would like to know more. So if you want to know more about the openEuler community, feel free to engage us with the following ways. On the left side is our social media accounts, and on the right side is our official website and ways to download and test out openEuler. So that's all for this session, and thank you all for your time and patience. I hope this is useful for you. And thanks again to the Open Source Summit to give us this opportunity. Thank you.